Three identical beakers A, B and C contain equal amounts of water at 30 degrees Celsius, 40 degrees Celsius and 65 degrees Celsius respectively. A. Water from beaker A is poured into beaker B. What will be the resulting temperature of the mixture? B. The mixture obtained in part A is now poured into beaker C. Determine the final steady temperature of water. The question is three identical beakers. Let me draw three identical beakers. Well, one more beaker of this type. I will select this and copy. Okay, again one more beaker. Okay. Well, we have got three identical beakers, and in these beakers water is taken. So okay, in this beaker water is taken, and same amount of water is taken in this beaker also. Same amount of water is taken in this beaker also. So the water taken in this beaker, let it be m gram. Oh, I'll change the color. Mass of water is m gram. Here water is again m gram, and here also m gram of water is there. And the first beaker, oh, they have given a name for the beakers. The name of the first beaker A, and second one is B, and the third one is C. A temperature of water in this beaker A is 30 degrees Celsius. Okay, and in B is 40 degrees Celsius, and in C the temperature is 65 degrees Celsius. Question. What is the question? Question says water from the beaker A is added to beaker B. Then what will be the resulting temperature of the mixture? Easy. Here heat is lost by hot water. Hot water means the water in the beaker B. Okay, that is of 40 degrees Celsius. And heat will be gained by cold water when I am mixing. So heat lost by hot water. Shall I write? Heat lost by hot water is equal to heat gained by cold water. Mass of hot water is this one. Oh sorry, this is hot water. Okay, mass of hot water is m. Specific capacity of water, that is C. Okay, hot water is losing heat energy, so it is a fall in temperature. Okay, so what is the temperature initially? That is 40 degrees Celsius. That temperature will fall down to a final temperature. So I do not know the final temperature. Let the final temperature be, or I'll write like this: temperature of mixture be T degrees Celsius. Actually, that is the first part of the question. Well, so this will be what? MC delta T. That's the fall in temperature for T minus T. Here heat gained by cold water. Mass of cold water is m. Specific capacity is same C. That's a rise in temperature. So what is that? From this 30 degrees Celsius, it reaches a temperature T degrees Celsius. That means here rise in temperature is T minus 30. Very easy. This MC and this MC will be cancelled. So situation is like this now: 40 minus T is equal to T minus 30. In other words, 40 plus 30 is equal to T plus T. That means 2 times T. 2 times T is equal to 70. T is equal to 70 divided by 2, 35. Okay, 35 degrees Celsius. What is the question? What will be the resulting temperature of mixture? Okay, so answer resulting temperature of mixture is equal to 35 degrees Celsius. Well, let us go for the second part of the question. What it is? In second part of the question, it says that this water, what is that? The mixture obtained in part A is now poured into beaker C. Okay, so this water was already taken into this, right? Well, everything is here now. Very good. And now they say that this mixture is added to this C. Okay, second part of the question. What is that? Heat lost by hot water. Here, which is hot water? Hot water is this one, this 65 degrees Celsius. That is hot water. Okay, so I'll repeat the statement. Heat lost by hot water. Heat lost by hot water is equal to heat gained by cold water. Here, what is the final temperature? Oh, we do not know. So let me write. Let the final temperature be T dash degree Celsius. I have already taken T there. So let us go for T dash this time. So it lost by hot water. So what is the mass of hot water? This one. M. So mass of water M, specific opacity is C, and that's a fall in temperature 65 minus T dash, right? Is equal to. So heat gained by cold water. Cold water is here. This is cold water. Okay. What is its mass? Remember that mass is 2 times M. 2M into C into, that's a rise in temperature. So it will be T dash minus, what was this mixture temperature? Already we have got that. What was that value? That value was, yes, 35 degrees Celsius. Okay, 35. Here also same story. This MC and this MC will be cancelled. So the situation is like this now. 65 minus T dash is equal to 2 times T dash minus 70. On rearranging, 65 plus 70 is equal to 2 times T dash plus T dash. That means 3 T dash is equal to 135. So T dash is equal to 135 divided by 3. What is that value? That is 4 3s are 12, 45. Okay, 45 degrees Celsius. So let us respond to the question. What is the question? Question is final steady temperature of water. Okay, so we will write that way. Temperature of water is equal to 45 degrees Celsius.